The next is multi-threading models. So in this we can see the types of threads we have. So user threads, kernel threads. So user threads, they are created and managed by the user. Okay, without the support of the kernel, they are used by the user. Okay, so kernel threads means they are supported and managed by the directly by the operating system. So here this kernel threads, they are managed by the kernel. Okay, and we know the user may interact with the operating system. Okay, and here there are two threads, that is user and kernel threads. So so in order to function together, this user and kernel threads, they must have relationship. Okay, and the type of relationship exists between the user and kernel thread, it is called multi-threading models. Okay, and there are three common ways of establishing a relationship. So what are they? Many to one to one, and many to many model. So let's discuss one by one. The first one is many to one model. Okay, so in the diagram you can see here, the first, it represents the user thread. Here there are four user threads and they are mapped into one single kernel thread. So here in the down, the circle represents the kernel thread. Okay, so here many user threads, that is multiple user threads are mapped into one single kernel thread. Okay, and it is the function. It maps many user level threads to one kernel threads. Okay, and here the thread management is done by the thread library in user space. So here the management of thread is done at the user space. So it is an efficient one. And what is this disadvantage here? The entire process will block if a thread makes a blocking system call. So here we have multiple user threads, and if any of the user thread it makes a blocking system call, then the entire system get blocked. Why? Because this user thread, it is mapped into this kernel thread. Okay, so if this user thread it makes a system blocking call, then it is associated to this kernel thread, right? And this kernel will get blocked. Okay, since the remaining three threads are associated with this kernel, and thereby all the system it gets blocked. Okay, so that is the disadvantage here. Next, second disadvantage, because only one thread can access the kernel at a time, multiple threads are unable to run in parallel on multi-core systems. So in multi-processor system, we know there are multiple processors running. Okay, and here there is only one kernel thread we have. So since even though we are having multi-processor systems, and here only one kernel thread is there. Okay, so only one thread can run on each processor. Okay, so one kernel thread can't run in two processor. One thread can run in only one processor. Okay, so that is the disadvantage here. So moving to the next relation, that is one to one model. Okay, so as you can see in the diagram, here one user thread is mapped to one kernel thread. Okay, so four user thread and they are mapped into individual kernel thread. Okay, and here it maps each user thread to a kernel thread. Okay, so it provides more concurrency than the many to one model by allowing another thread to run when a thread makes a blocking system call. So in the many to one, we have see what is the disadvantage. If any one of the user thread it makes a blocking system call, then the entire system gets blocked. And here each user thread is mapped into only one kernel thread. So if any one of the user thread it makes a system call, then only the thread which is associated with the kernel thread it gets blocked. Okay, not the entire system goes wrong. Okay, and here it allows multiple threads to run in parallel on multiprocessors. So which means here we having one user thread to one kernel thread. Okay, and if there are multiple processor, so multiple processor இருந்துச்சுன்னா ஒவ்வொரு ப்ராசஸர்லையும் இங்க 4 threads இருக்கு ரைட்டா. ஸோ ஒவ்வொரு கர்னலும் ஒவ்வொரு ப்ராசஸர்ல என்ன ஆகும் ரன் ஆகும். ஓகே, so that's the thing here. And what is the disadvantage? Creating a user thread requires creating the corresponding kernel thread. Okay, so ஒவ்வொரு user thread நம்ம create பண்ணும்போது we have to create the corresponding kernel thread also. Okay, and here because the overhead of creating kernel threads can burden the performance of an application, most implementations of this model restrict the number of threads supported by the system. So ஒவ்வொரு யூசருக்குமே இண்டிவிஜுவலா நம்ம ஒவ்வொரு யூசர் த்ரெட்டுக்கும் ஒவ்வொரு கர்னல் த்ரெட் வந்து நம்ம கிரியேட் பண்றது இட்ஸ் அ little bit complicated. Okay, so somewhat costly. Okay, and சில அப்ளிகேஷன்ஸ்ல லிமிட் வச்சிருப்பாங்க இவ்வளோ கர்னல் த்ரெட்ஸ் தான் கிரியேட் பண்ண முடியும். ஓகே, ஸோ தட்ஸ் த டிஸ்அட்வான்டேஜ் ஹியர். ஸோ அப்படி பார்த்தா நம்ம எல்லா யூசர் த்ரெட்டுக்குமே ஒரு கர்னல் த்ரெட் கிரியேட் பண்ண முடியாது அந்த சுச்சுவேஷன். ஓகே, ஸோ தட்ஸ் த ட்ராபேக் ஹியர். அண்ட் moving to the last relationship, that is many to many model. Here you can see many user threads that are here. There are 4 user threads. They are mapped into 3 kernel threads. Okay, so many to many. So many user thread can be associated with equal or some lesser number of kernel threads. Okay, inga 4 user threads, they are mapped into 3 kernel threads. So 4 to 4 or 4 to below 4. Okay, so multiplexes many user level threads to a smaller or equal number of kernel threads. So equal number of kernel threads கூட மேப் ஆகலாம், இல்லைன்னா அதை விட கம்மியா மேப் ஆகலாம். இங்க 4 user threads and 3 ஒரு thread வந்து கம்மியா இருக்கு ஒரு kernel thread. Okay, that's given here. And here the number of kernel threads may be specific to either a particular application or a particular machine. So kernel threads வந்து எவ்வளவு மேக் பண்ணலாம்னு அந்த particular application பேஸ் பண்ணி இருக்கும். சில applications or சில system வந்து they restrict the number of kernels, இவ்வளோ kernel threads தான் create பண்ண முடியும் அப்படின்னு restriction இருந்துச்சுன்னா அதை பேஸ் பண்ணி தான் the number of kernel threads creation இருக்கும். Okay, next, developers can create as many user threads as necessary, and the corresponding kernel threads can run in parallel on a multiprocessor. So developers can create many user threads. Okay, so user can create many user threads as necessary, and the corresponding kernel threads can run in parallel on a multiprocessor. So இந்த user thread க்கு correspondent ஆன kernel thread எங்க run ஆகும்? If it is a multiprocessor system, and here the kernel, each kernel thread can run on one processor. Okay, also when a thread performs a blocking system call, the kernel can schedule another thread for execution. So if any one of the user thread it makes a blocking system call, then the system, okay, so what the system will do, the kernel can schedule another thread for execution. Kernel என்ன பண்ணும், இப்போ இந்த user thread வந்து if it makes a blocking system call, then the kernel associated to that user thread it goes wrong or it gets blocked. Okay, and then in such situation the kernel it will schedule another thread to resume its execution. Okay, so here another one variation is here. One variation on many to many model is 2-level model. Okay, that is many user level threads to a smaller or equal number of kernel threads, but also allows a user level thread to be bound to a kernel thread. So see this diagram here, many user threads are mapped into equal or smaller number of kernel threads. So plus அது கூட additional ஒரு user thread is associated to one kernel thread. So this is a two-level model. Okay, so that's all about multi-threading.